Before the advent of starlight, before the silent ballet of galaxies, before the very notion of time as we comprehend it could take root, there was a state of existence so utterly alien to our present universe that language itself falters in its description. The genesis of all that is, all that ever was, and all that will be, is an event shrouded in the impenetrable veil of the earliest conceivable moment, a genesis that our most audacious scientific inquiries have termed the Big Bang. It was not an explosion in a pre-existing void, for space itself was bound within this nascent cosmos. Rather, it was an unfolding, an unfurling of reality from a condition of unimaginable density and temperature. Imagine the entirety of the observable universe, with its billions of galaxies and countless stars, compressed into a volume infinitesimally small, a point of such extraordinary energy concentration that the laws of physics as we currently understand them cease to operate, yielding to a realm where quantum effects and gravity merge in a manner yet to be fully deciphered. This was the singularity, a theoretical boundary or starting point of space-time, not a place, but a condition. From this primordial state, the universe embarked upon a journey of expansion, a relentless outward surge that continues to this day, carrying the tapestry of space-time along with it. In the merest fractions of a second, smaller than any human intuition can grasp, a period known as the Planck epoch, lasting approximately 10 to the power of -43 seconds. The conditions were so extreme that the four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, are theorized to have been unified into a single, all-encompassing superforce. As this nascent universe began its breathtaking expansion, it also began to cool, a crucial process that would allow complexity to emerge from the initial, almost featureless, homogeneity. This was not a gentle cooling, but a series of dramatic phase transitions, cosmic demarcations, where the fundamental architecture of reality was being laid down. The initial moments were a maelstrom of pure energy, a seething quantum foam from which particles and their antimatter counterparts would flicker in and out of existence, a universe pregnant with potential but devoid of structure as we know it. The journey from this unimaginable beginning to the cosmos we observe today is a story of transformation on the grandest scale, a testament to the intricate interplay of fundamental laws, and a sequence of pivotal events that sculpted the universe from its fiery birth. The immediate aftermath of the Planck epoch ushered in a series of crucial epochs, each characterized by the decoupling of fundamental forces and the emergence of the elementary particles that constitute the building blocks of matter. The Grand Unified Theory, GUT, epoch, spanning from the end of the Planck epoch to roughly 10 to the power of -36 seconds, witnessed the separation of gravity from the other three fundamental forces, which remained unified. It is within this epoch that some theories propose the occurrence of cosmic inflation, a period of extraordinarily rapid, exponential expansion, where the universe is thought to have increased in size by a staggering factor. Inflation provides a potential explanation for several observed properties of the universe, such as its remarkable uniformity on large scales and the subtle temperature fluctuations in the cosmic microwave background radiation, which would later serve as the seeds for the formation of galaxies. Following the GUT epoch, the strong nuclear force decoupled from the electroweak force, electromagnetism, and the weak nuclear force during the electroweak epoch. This separation allowed for the emergence of fundamental particles like quarks and leptons, the basic constituents of matter, and the force carriers that mediate their interactions. The universe at this stage was still incredibly hot and dense, a primordial soup of energetic particles constantly interacting and annihilating each other, leaving behind a slight asymmetry between matter and antimatter, a crucial imbalance that ultimately led to the dominance of matter in the present universe. Had matter and antimatter been perfectly balanced, they would have completely annihilated, leaving behind only photons and a universe devoid of the material structures we observe. The exact mechanism responsible for this baryogenesis, the creation of an excess of baryons, protons and neutrons, over antibaryons, remains one of the most profound unsolved mysteries in cosmology. As the expansion continued and the temperature dropped further, the universe entered the quark-gluon plasma epoch, where quarks and gluons existed freely, unconfined within composite particles. It was not until the universe cooled sufficiently, approximately 10 to the power of -6 seconds after the initial singularity, that quarks and gluons began to combine to form protons and neutrons, the baryons that constitute the nuclei of atoms. This event marked the end of the hadron epoch and the beginning of the lepton epoch, where leptons, such as electrons and neutrinos and photons, dominated the energy density of the universe. The continuous expansion and cooling were setting the stage for the next pivotal event, the formation of light atomic nuclei. As the universe continued its relentless expansion and cooling, passing the threshold of the first second, the stage was set for the primordial forging of elemental matter. With temperatures still in the realm of billions of degrees Kelvin, protons and neutrons, now existing in the sea of leptons and photons, possess the kinetic energy to overcome their mutual electrostatic repulsion and fuse, initiating the era of Big Bang nucleosynthesis. This brief but crucial window, lasting only for a few minutes, from roughly 1 second to about 20 minutes after the initial event, saw the birth of the first atomic nuclei. Protons and neutrons combined to form deuterium, an isotope of hydrogen, which then further fused to create helium-3 and, most significantly, helium-4, the second most abundant element in the cosmos. Trace amounts of lithium were also synthesized during this period. The remarkable precision with which theoretical calculations of these light element abundances match observational data gleaned from ancient stars and distant gas clouds stands as one of the most compelling pillars of evidence supporting the Big Bang model. Once this period of cosmic alchemy concluded, the universe was still far too hot and dense for neutral atoms to exist stably. For hundreds of thousands of years, it remained an opaque, seething plasma, a cosmic fog composed of these newly formed atomic nuclei, primarily hydrogen and helium, and a vast multitude of free electrons, all bathed in an intense field of photons. These photons, carriers of electromagnetic energy, were constantly scattered by the free electrons, unable to travel any significant distance unimpeded, rendering the universe a visually impenetrable realm. This phase is often referred to as the photon epoch, where radiation, not matter, was the dominant influence on the universe's dynamics. However, the universe did not cease its expansion, nor its cooling. Gradually, over an immense span of time, the temperature dropped to a few thousand degrees Kelvin. This cooling eventually reached a critical juncture, approximately 380,000 years after the Big Bang, when the universe became sufficiently cool for the electromagnetic attraction between the positively charged nuclei and the negatively charged electrons to overcome the disruptive energy of the ambient photons. Electrons began to combine with nuclei, forming stable, electrically neutral atoms, a process known as recombination. This was a transformative event. With electrons now bound within atoms, the primary impediment to the free travel of photons was removed. The universe, once an opaque fog, became transparent, allowing light to stream freely across the vastness of space for the first time. The photons that were present at this moment of decoupling, now liberated, embarked on an eternal journey, carrying with them an imprint of the universe as it was at that early epoch.